Today we will be continuing our notes on bonding, and we're going to be focused specifically on ionic again, but we're going to be going a little bit more in depth. All right. So today, for this, you do need to make sure you've got your notes, something to write with. You'll need a periodic table, and then you will also need your list of polyatomic ions that can be found posted on Canvas. All right. So once you got all those things, let's go ahead and get started. So for this set of notes, you do need to know what a polyatomic ion is. So what is a polyatomic ion? Well, a polyatomic ion is a multi-atom polyatomic ion. So what does it mean to be an ion? It means that it's got a charge. So it is this essentially multi-atom compound that we've created that ends up with a charge. Now we're going to be using these polyatomic ions to actually form bonds with other substances, other elements from the periodic table. Okay, so how do we do that? Well, first off, what is this? Well, this is what we call a ternary ionic compound. Now, ternary means more than two. Okay, so we've got binary compounds, which would be compounds made of two elements. And we've got ternary compounds, which are compounds made up of three or more elements. Okay? So ternary compounds are going to include some of your polyatomic ions. So let's actually look at how we do this. Okay, so let's look at polyatomic ions. So for this, if I am using a polyatomic ion and I need to add a subscript after it, a very important thing that you need to remember to do is to add parentheses around that polyatomic ion. Why? Because it's that whole polyatomic ion that has that charge. So when you're trying to solve for what is the compound, what is this after we do the swap, drop, reduce, after we cancel out those charges, when you're doing that, you need to make sure your polyatomic ions are in parentheses. Okay? So what does that look like? So here I've got calcium. Calcium has a +2 charge. Remember, it's got a +2 because it's got two valence electrons, so it's more likely to lose 2 electrons. So calcium's got a +2. Phosphate has a -3. So to cancel those out, we swap them. So the 2 goes to the phosphate, the 3 goes to the calcium. We drop them, the 3 comes down, and then last we would reduce. All right, now this is actually the wrong way to write it. Why? Because we did not add parentheses around that. So you do need to make sure that when we're talking about polyatomic ions, if you end up with more than one, like we did right here, you have to put parentheses around it. And so this is the correct answer for that. Okay, right here, I've got ammonium and I've got sulfate. So that would be ammonium sulfate. So looking at this, we got our +1 and we've got our -2. We swap those charges, we drop them low, and then we reduce. So I swap the charges. The 1 goes over to the sulfate, the 2 goes over to the ammonium. I drop them down low. Remember, anytime we've got a 1, the 1 just goes away. And then I reduce. Now, again, this is not right because we added this number over here. So we do need to make sure that that subscript is going to be outside of the parentheses for the polyatomic ion. Okay, so then this again would be our correct formula. So let's take a look at writing some actual compounds. So I've got sodium and I've got hydroxide. So first off, let's go ahead and write our atomic symbols. So sodium is Na. Na is in group 1. So it's going to have a +1 charge. Then I've got hydroxide. Now, a common mistake is thinking of hydroxide as hydrogen or oxygen. It's not. It's a combination of the two. So you'll use your polyatomic list. You'll find hydroxide, and you'll find that it is OH with a -1 charge. So now we would swap, drop, reduce. I'm actually going to use 2 different colors. I'm going to use green for my hydroxide here just to kind of help keep track of everything for y'all. So OH -1. So we would swap it. When we swap it, this turns into Na, swap the charge so that 1 comes over, OH, sorry, that should be green. OH, and then the 1 from the sodium should come over here, 1. And remember, you never bring your positive or negative, it's just the number. Okay? Now, I've got NaOH. I've swapped them. Now I need to drop them. So in A, the 1 comes down. You got OH. The other 1 comes down. And then remember, if you've got a 1, you just don't write the ones, right? So these would go away. So our final compound is NaOH. That would be our formula. Okay, so I'm going to do one more with y'all, and then I'm going to have y'all do a couple on your own. All right, so I've got ammonium chloride. So what is ammonium? Well, common misconception is ammonium is aluminum. It's not. Ammonium is a polyatomic ion, so you are going to need to find that. You'll look on your periodic table, and you find ammonium is NH4 with a positive 1 charge. Now, remember, you can just put a plus. You don't have to put +1 there. And then I've got chloride. Well, what is chloride? Chloride is Cl. Chlorine is in group 17, so it's got a -1 charge. So Cl with a minus. And then we swap, drop, reduce. So I get NH4. The 1 from the chlorine comes over. Then Cl. And then the 1 from the ammonium comes over. And then we drop them low. So then NH4. If it's a 1, we can just leave it blank, right? And Cl. There's nothing to reduce. So we would get NH4Cl as our final answer. NH4Cl. Okay, so now I've done 2 with you. So what I want you to do is go ahead and do the next 4. All right, do the next 4. I'm going to go ahead and write the answers, but I want y'all to pause your video, do the next 4, and then we'll go over it. All right? All right, so let's take a look at these. So I've got calcium nitrate. So calcium has a +2 charge. Nitrate has a -1 charge. Nitrate is NO3. Again, you would check your polyatomic ion list. So I would swap, drop, reduce. So my calcium, get a highlighter here, maybe. So I have my calcium +2, nitrate -1. We swap, we go to a 1 and a 2. So we get Ca with the 1 charge. Remember, you don't bring your positive or negative. NO3 with the 2. We go over, we drop them now. So Ca turns into NO3 with a 2 down there at the bottom. And remember, it is a polyatomic ion with more than 1, so you do have to put it in parentheses. And so then I rewrote it as CaNO3 2. All right, let's take a look at this next one. So I have potassium dichromate. So potassium is a +1. Chromate is a -2 charge. It is Cr2O7. So then we would swap, drop, reduce. So the 2 from the chromate comes over to the potassium. 1 goes over to the chromate. You drop it down. You get K2Cr2O7. Aluminum silicate. Aluminum has a +3 charge. Silicate, which is SiO3, has a -2 charge. So then we would swap, drop, reduce. The 3 from the aluminum goes over to silicate. The 2 from the silicate goes over to the aluminum. Drop it down. You get Al2SiO3 3. And you do need to remember your polyatomic ion in those parentheses. Last one, calcium sulfite. Calcium is a Ca with a +2 charge. Sulfite is SO3 with a -2 charge. Swap, drop, reduce. And so I did actually emphasize that here. I've got to reduce. And so because I've got a 2 on the bottom here and a 2 on the bottom there, that's going to cancel out. And so we'll end up with CaSO3 as our final answer. All right. So that would be how we would use our polyatomics in terms of writing the formula. So let's take a look at our name. So for naming, what we're going to do is we just need to find our polyatomic ion. First off, I need to recognize that this is ionic. If I've got a cation and an anion, it is an ionic compound. So here I've got KCN. Okay, well, what is my polyatomic ion there? I know I'm looking for that because I've got a ternary molecule here, right? I've got more than two things. I know it's going to be ionic because I do have a metal in there. So taking a look at this, I've got a potassium and I've got Cn, which is a carbon and a nitrogen. So I would look at my list and I would find out that Cn is cyanide. So the nice thing about ionic compounds is you essentially just write them as their name is. So K would be potassium. And Cn, we already learned, was cyanide. So it is potassium cyanide. Okay, so let's do another one. I've got SrPO4 SR3PO4 2. Well, first off, if they do tell you that there is a parentheses there, you know there's a polyatomic ion, right? So since I know it's a polyatomic ion, it's going to have to be an ionic compound. So when we name it, we are just going to use our names. So Sr, I look at my periodic table, and I find Sr is strontium. So strontium. And then I know that PO4 is a polyatomic ion. Why? Because it's in parentheses. So I would look at my polyatomic ion list, and I find that PO4 is phosphate. So that would be strontium phosphate. All right, so what I want y'all to do is to try to name the next four, and then we will go over them. All right, so pause your video, name them, and then unpause and we'll go over them. All right. All right, so hopefully you'll pause your video, but let's go ahead and go over these. So I've got MgSO4. Well, first off, there's not a parentheses, so I need to find that polyatomic ion. I've got a metal, magnesium, and then I've got S, and then I've got O4. Well, so looking at that, I know that my polyatomic ions are going to be nonmetals bonded with typically a metal. Sometimes you'll have another polyatomic ion, but typically a metal. So I've got a metal bonded with a polyatomic ion. Magnesium bonded with the polyatomic ion sulfate. So this would be magnesium sulfate. Over here, I've got calcium and I've got ClO3, 2. So I know that this ClO3 is going to be my polyatomic ion. Since I know it's a polyatomic ion, I can think about that. I've got a chlorine with 3 oxygens. Chlorine with 3 oxygens is chlorate. So then I would write out my name. I've got calcium and it's bonded to a chlorate. So this would be calcium chlorate. Okay, moving on. I've got NH4F. So I've got NH4. Well, NH4 is essentially your only polyatomic ion with a positive 1 charge. So since you've got that, NH4, then you know that that's your polyatomic ion. And then I've got F, which is a nonmetal. So looking at this, you're like, okay, well, that might be a covalent compound. But we've got a polyatomic ion there, NH4. So that does make this an ionic compound, okay? Because part of being ionic is you've got to have that charge that's being canceled out. So I've got NH4, which is ammonium. And then I've got F, which is fluoride or fluorine, right? But when it's in a bond, you put that "ide" on the end. So this would be called ammonium fluoride. Last, I've got the strontium, and then I've got a carbon, and I've got a nitrogen. Well, we've already looked at that having a parentheses around it. Since it's got a parentheses, that tells me that that is a polyatomic ion. So this would be strontium with a polyatomic ion of cyanide. So this would be strontium cyanide. All right? All right. So that would be us writing names for our polyatomic ions. So let's move on to transition metals. Now, y'all know that we've talked about transition metals in the past as kind of having this kind of different thing that happens, and that's why we kind of don't talk about them having a certain charge or anything like that. Well, the reason that we talk about transition metals in that regard, in that way, is that transition metals can actually have different charges. So sometimes they could have a +1 or a +2 or 3 or 4 or 5 or 6. And so because of that, we need to do different things depending on what transition metal we're talking about. And we have to signify what that charge actually is. Okay? So remember, your transition metals are going to be the metals that are from groups 3 through 12 on the periodic table. And they can exist with different charges, what we call oxidation states. And this is due to those unpaired electrons. And so remember when we talked about electron configuration, we did that orbital diagram. When you drew those up arrows, those unpaired electrons are what we're kind of talking about when we're talking about this transition metals having these different charges. Now, most transition metals are going to require a Roman numeral. Now, that Roman numeral is what's going to tell us what the charge of the specific element is. Okay, so if I'm looking at copper, so Cu, and I see it's got a +2. So it's got a Roman numeral of the two I's up and down, right? Then that would tell me that it's got a +2 charge. Okay? So real quick, let's actually go through our Roman numerals, make sure y'all know what they are. So I would be 1. If you do it like that, it would be 2. 3 I's would be 3. If we have an IV, that would be 4. It stands for 1 before 5. Then you have V, which is 5. And then we would go 1 after 5. That would be 6. And then 2 after 5 would be 7. And then 3 after 5 would be 8. And then we would do 1 before 10, which is going to be 9, and then X would be 10. So those would be your Roman numerals that you would use potentially for your different charges. All right? Now, you're always going to use a Roman numeral with your transition metals unless it is one of 3. Okay? So there are 3 transition metals that do not require a Roman numeral. Those 3 transition metals are zinc, silver, and cadmium. Why? Because they always have the same charge. Since they've always got the same charge, we do not use a Roman numeral because the Roman numeral is redundant. Okay? And so with all of our other transition metals, we don't know what their charge is without having that Roman numeral. But these 3, we know that they are always the same charge. So we do not use a Roman numeral for them. Okay? So cadmium is always a +2. Zinc is always a +2, and silver is always a +1. All right? The very last thing is you do have mercury, and mercury is kind of its own thing. It does kind of its own thing. And so mercury 1, which you're like, okay, well, that's got a charge of 1, but this is actually mercury 1. So mercury 1, there are 2 of them, so combined they give us a +2 charge. Okay, so that's something that you are going to have to remember is that mercury 1 is actually 2 mercuries with a +1 charge, which means they're going to have a combined charge of 2. Okay. All right. So now that we know kind of in general what we're going to be doing with our Roman numerals, let's actually dive on into this and see what it looks like. So here I've got copper with a 2 and then fluoride. So copper 2 fluoride. So what does that look like? How do I actually write the formula for this? So I know that copper is Cu, and this 2 right here tells me what the charge is for the copper. So copper has a +2 charge. Then I've got fluoride. Fluoride is F. Well, what charge does fluorine have? -1. So then we would swap, drop, reduce. So we would swap Cu1, F2, drop them down. So 1 goes there, 2 goes there. So this becomes Cu, and remember you don't write a 1, F2. So that would be the formula for that. Now I did condense this a little bit more because hopefully y'all are kind of getting the hang of how to swap, drop, reduce. But we can always walk through it. You can always walk through it again. Make sure you rewatch the video on Simple Ionic if you need some help with that swap, drop, reduce. Okay? All right, so let's take a look at this next one. I've got lead 4 nitride. So lead is Pb. I know that it's got a 4 charge. Why? Because, again, they told me that its charge is plus 4. And then I've got nitride. Now, what is nitride? Well, it ends in IDE. And the only other thing that's not just an element that ends in IDE is cyanide. Since that's not cyanide, I know it's just the element, which is N. N has a charge of -3 because it is in that group 15. So then we would swap, drop, reduce. So Pb, we get a 3 from that. N, we get the 4 from the lead. That's swap. Then we drop them down, 3 and 4. So then this turns into Pb3N4. And that would be my compound. That would be my formula. Okay? All right. So what I want y'all to do is to pause your video, go ahead and do the next couple, and then we will go over them. Now, these I am just going to write the name or the formula for them. So I'm going to be skipping the swap, drop, reduce step. So I'll write your symbols with their charge, and then I will just write the formula after I swap, drop, reduce. All right. So pause your video, work through them, and then we'll go over them. All right. So let's take a look at this. So I've got tin with a 3 charge and bromide. So Sn is 10 with a 3 charge and Br is bromide with a -1 charge. I swap, drop, reduce, and I should end up with SnBr3. Okay, moving over here. I've got molybdenum 5 telluride. So molybdenum is Mo. It's got a +5 charge. And then I've got telluride, which is Te. It's got a -2 charge because it's in group 16. Swap, drop, reduce, we get Mo2Te5. Moving on, I've got cadmium and I've got nitrate. Now this time it is a little bit more tricky because we do have a transition metal, but we've also got a polyatomic ion. I know that because it ends in 8. Polyatomic ions are typically going to end in 8 or ite. Okay, so I've got cadmium. Now, cadmium is that transition metal that you do not actually need the charge to be listed for you because it is always a +2 charge. So cadmium's got a +2 charge, nitrate's got a -1 charge, we swap, drop, reduce, and we get CdNO3, 2, with that NO3 being in a parentheses because it is a polyatomic ion that has more than 1. All right? Okay, very last one, I've got iridium with a +3 charge, sulfate, which has a -2 charge, and then I swap, drop, reduce, I get Ir2, and then in parentheses, SO4 with a 3 on the outside of that parentheses. All right, so that would be it for that. Now, the very last thing is writing the name for your transition metals. Okay, so writing the name for our transition metals. Now, for this, we do need to know what the charge is of the transition metals because remember, for your name is always going to have that charge if there's a transition metal. So you're going to need that Roman numeral, which means you need to know what the charge is of that of that transition metal. All right, so I've got lead and oxygen here. So I've got PbO2. So you're like, okay, well, how do I figure out what the actual charge is for lead? Well, what you need to do is you need to make sure that your charges all cancel out. So the total side of the negative needs to equal the total side for the positive. So I have oxygen. I do know oxygen has a -2 for its charge, right? Well, I've got two -2 charges because I've got 2 oxygens. So my total charge coming from oxygen is -4. Right? 2 times -2 gives me -4. Now, again, I know that I want my compounds to cancel out. I want my positive and my negative to cancel out, which means I want them to equal 0, right? So I've got my -4 and I want it to equal 0. So what do I need? I need a +4, right? So I need a +4 from over here. So I look and I say, okay, well, I have 1 lead and I want its total charge when it's all said and done to equal +4. So what does lead's charge have to be? Well, lead's charge has to be a +4. Okay, so now I know what its charge is, so now I can write its name. So lead is Lead. I now know its charge, so I can, in parentheses, put the Roman numeral for 4, IV. And then I have oxygen, which, remember, when we write the name for that nonmetal, for that anion, it's going to be changing its ending to "ide." So that would be lead 4 oxide. Okay, so let's try another one. So I have manganese and I have sulfur. Manganese, I don't know, because manganese is a transition metal. I do know sulfur, though. Sulfur is a -2 charge. Okay, so now I know that sulfur has a -2 charge. I've got one sulfur, right? So one sulfur times its -2 charge gives me a total of -2, and I want that to equal 0 to cancel out. So I need a +2 total over here. So then my manganese is going to need a +2 for its charge as well. So then I'm going to do manganese, and then its charge, 2, and then the nonmetal, the anion, so sulfide. Okay, so what I want you to do is to pause your video, work through these next few problems, and then we will go over those 4. All right, so pause your video. All right, so let's look at these. So I have iron and fluoride. So iron, and then there are 3 fluorines there. So I know that fluorine has a -1 charge. I've got 3 of them, so the total amount of charge is -3. And then I know that to cancel that -3 out, I need a +3. So then I need a +3 coming from my iron, since there's only one of them. Okay, so then my name would be iron 3 fluoride. Okay, moving on. Now I have yttrium with 2 and sulfide with 3. I don't know yttrium, but I do know sulfur has a -2 charge, and I've got 3 sulfurs. So 3 times -2 gives me a total of -6. To cancel that out, I need a +6, but I have 2 yttrium this time. So since I've got 2 and combined, they need to add up to 6. 2 times what number will give me 6? 2 times +3 gives me 6. So then I have yttrium with a 3 charge and then sulfide. So it's yttrium 3 sulfide. Okay, moving on. I've got osmium with 2 of those, and then I've got carbonate with 3 of those. So then I have carbonate. I know that its charge is a -2 charge. It is on my list of polyatomic ions. So 3 times -2 gives me a total of -6. I need to cancel that out. So then I need a +6. I have 2 osmium there. So 2 times what number gives me a +6? 2 times 3. So I know my charge for osmium is 3. So osmium 3 carbonate. Now this last one is a little tricky. Now the reason it's tricky is because I've got my polyatomic ion here, phosphate. How many phosphate do I have though? I've only got 1 phosphate. And so I do need to recognize that while my phosphate has a -3, there is only 1 of them there and not 4, okay? Because all of this is phosphate, okay? So if I had that in parentheses with a number outside of it, then I would multiply my charge by that number. But I don't here. So I have a -3, so my total charge is -3, and I want that to equal 0, so I need a +3 to cancel that out. I've only got 1 vanadium. 1 times what charge will give me that +3? 1 times a 3 charge. And so I know that my name for vanadium with this phosphate here is vanadium 3 phosphate. All right, y'all. So that is it for our polyatomic ions and transition metal rules for ionic compounds. Let us know if you got any questions, but otherwise I hope y'all have a great rest of the day. Bye, y'all.